So this is joint work with John Bashairs at Stanford, James Choi at Yale, and Bridget Madrian at Harvard. And this is about the differential impact of defaults and how we want to kind of, as defaults become the norm for lots of different interventions, how we might want to better understand how defaults work and in particular who they work on. So I think data like this is familiar by now. If we think about the impact of default enrollment, it's pretty large. And we can look at firms that did not have default enrollment in the 401k plan and look at the enrollment rates at a year of tenure. So 38% for company A, 40% for company B, 50% for company C, and at this point there are dozens and dozens of companies that have been studied. And then you introduce auto enrollment and you get this night and day difference. So we now know that auto enrollment makes an enormous difference. We don't really know entirely why. So why are defaults so sticky? One possible answer, one appealing answer would have been that defaults are sticky because we're moving people to the right place. We're getting them to where they should be and they stay there. So when we see that low-income households are so likely to stick with not only participation, but also with the default the default contribution rate that we set for them, we might say that's terrific because, look, a 3% default savings rate really is appropriate for a low-income household, given the high rate of Social Security replacement income that they're going to get, or as we learned from Olivia this morning, the low level of financial literacy they might have, and hence the low rates of returns they might be expecting, and hence the kind of lack of benefit of saving. But for whatever reason, one might think that these households are sticking because we've moved them to the right place. A less rosy interpretation is that people are sticking because they're confused, because they just passively do what they're told or stick where they're placed, and they'll even stick in gravely suboptimal places. So they'll even stick in a savings plan they shouldn't be in, or at a savings rate that is inappropriate for them. So how would we kind of separate these stories? Well, there's an answer, which is to find a suboptimal default and to look to see who sticks there. So what we're going to do to understand how defaults work is kind of go to a rather bizarre case where we have endeavored over many years to find a default that is really bizarrely bad and look to see who stays at that default. And you'll see that it's bizarrely bad in a particular way that makes it not just bad for everyone, but particularly bad for low-income households. So they really shouldn't be sticking at this default. And if they do, it's a sign of a mistake and decision-making pathology. Okay, so here's the context of this bad default. So we're studying a large company, and a large company has a really extraordinary system of matching employee contributions. They're going to have a 100% match on contributions between 12% and 18% of income. In particular, they're not going to match a penny on the first 12% of your income. So if you put in 12% of your income to the plan, you get 0 matching dollars. Your first matching dollar comes when you go from 12% contribution rate to 13% contribution rate. And they're going to match 100% as you go from 12 to 13 to 14 to 15. But if you put in 12, not a penny of matching dollars. So now let me give you a kind of personal finance IQ test. What contribution rate is very hard to defend as an optimal contribution rate in this plan? What would you kind of argue if you kind of took first-year economics is just almost impossible, really impossible to defend as an optimal savings rate? 12%, exactly. So 12% is just nonsensical, and I'll show you in a second the formal argument, but it kind of makes no sense intuitively that you would save 12% because you've picked the maximal savings rate at which you get no matching dollars. And if you just put another penny in, you'd start the good stuff. So if you're willing to go to 12, basically you should definitely be willing to go to 13 because the marginal value of the next dollar is twice in terms of the match, the value of the last dollar that you put in. So to see that formally, Well, actually, sorry, let me just now say, you see where I'm leading. At this company, the default savings rate happened to be 12%. It was the one number that economic theory says is not the optimal savings rate. So here's the setting in the language of first-year economics. We put present consumption on the horizontal axis and future consumption on the vertical axis. So at this company, it turns out that you have to put in at least 4% of your pay. The company obligates you to put in at least 4%. So the game starts consuming 96% of your current income. You can't consume more than that. And as you decrease your current consumption dollar for dollar, you raise your future consumption dollar for dollar. I'll ignore interest here. Until you get down to a 12% savings rate, which is consuming 88% of your current income. And then this line doubles in slope. And it remains at that double slope until we get out to an 18% savings rate, corresponding to 0.82% of your current income. And then the slope reverts again to a one-for-one slope. So in the language of first-year economics, if you think about indifference curves in this space, the indifference curve tells me kind of at which point utility is the same as I move across combinations of present and future utility. And generally, those indifference curves are smooth curves. And now you can see it's going to be impossible to have an indifference curve that lands at this kink point here. Because any smooth curve is going to have a tangency away from this kink point or on that concave kink point, but never on this convex kink point. That's just an impossibility. And if this first-year principles of economics version isn't appealing, just think about it the following way. If I'm willing to drive up my savings rate all the way down to 12%, well then savings was worth it when I went from 11% to 12%, which means it's still going to be worth it when I go from 12 to 13, because now I'm getting this extra huge bonus of an extra dollar of income from my employer. So this point just cannot be an optimum. But that point is the default. So we're going to see who sticks at that point. So let's first kind of think about the behavior at this firm, and it's going to look very different from the behavior that we're used to seeing in US firms. There's a lot of people exiting the default at this company for all the reasons that we just discussed. So everyone in the beginning of their tenure, I can actually use a laser pointer here, I need to crawl all over the screen. Everyone begins at the default, and within the first month, we already see about 20% opting out. And to interpret the opt-outs, blue means you're at the default, green means you opted out to a savings rate below 12%, red means, it's kind of an odd one, you opted out of the 12% default, and then you ended up back at the 12% default. So there's a small number of people who, for whatever reason, who knows whether that goes to the machine or some kind of accounting, logistical paperwork error, or just they're very, very confused. But for whatever reason, they came in and out, and they're back at the 12% default, having opted out from it. And then yellow means that you opted out to an even higher savings rate, and you're getting this extra matching money. So we can see that when we go out to a year of tenure, 75% have terminated the default savings rate of 12%. That's good news. So one message is we are not kind of blind lemmings following the default over cliffs. If anyone thought that was the case, I mean, no economist would have ever thought that, but if some wild-eyed behavioral economist like me ever thought that, that's not true. 75% are escaping the default, and it's a bad default, so we're happy to see that. Okay, so where do they escape to? Well, as you might expect, these are the ones who kind of stay at the bad point. When they escape, they either tend to go down to 4, which is, again, the minimum number. Ignore the man behind the curtain. We don't know how people get there. We've talked to the firm, and there's all sorts of stories about weird circumstances where you can get below 4, even though 4 is the official rule. If you kind of join the firm and quit and join again, ignore that kind of footnote. And then a lot of them are going up here to 18, where they're getting the full match. So if you go to 18, you're getting matched 100% for each of these additional increments of savings. So now let's come to the question of what is the population of people that stick at this really perverse default? And again, this is a particularly perverse default for low-income households, because low-income households should not be saving 12% of their income. That's not even a recommendation to those households. You know, they should be saving a lot less. So what we're showing you here is we're showing you average income. It's log average income, or it's the average of log income for populations who have ended up at different contribution rates in the plan. And these are personal contribution rates. They don't include the employer match. And I've omitted the data at this point here. And so let's think about this data, and then we're going to kind of reveal where that point is. So as you might expect, people with high income tend to pick high savings rates. People with low income tend to pick low savings rates. And of course, since we're on a log scale, going from 10.2 to 11.0 is like an 80% increase in income. So you just, 0.8 difference amounts to an 80% difference in income. So these are the people who opted out. These are the people who did something active and expressed their preference by making an affirmative choice for the different savings rate. What about the people who stuck at the 12% savings rate? What do they look like? Are they on the regression line? So if people with average income of 10.5, 10.6 ended up sticking at the default, no problem. That would be the outcome. The appropriate people stayed. Here's the data. So, in fact, the people who stick have the lowest income of all. So they're the most, in our interpretation, unsophisticated. They probably have the lowest human capital. We associate income with education. So we're seeing in this data and other firms that we've studied that I won't tell you about today, a robust pattern of people at the default tending to have unexpectedly low levels of income. Now, in a complicated way, that's not going to be true at the very, very bottom for other firms when we pick a very, very low default rate, because in some sense there's also a kind of average employee effect. So you'd expect as the default gets lower, this gap to get smaller, which is exactly what we see in the data. Now we can also run a regression analysis and kind of make this more quantitative. Like we put employee salaries on the left-hand side of the equation, and we ask, what does sticking to the default predict about employee salaries? Sticking to the default predicts a 35% reduction in the employee salary. Those who stay are paid 35% less than those who opt out of the default. So the default is really an indicator. Sticking to the default is really a powerful indicator of low levels of human capital, low SES levels, probably low levels of financial sophistication. Okay, so let me conclude. That really took 15 minutes. I'm impressed. I thought I had 10 minutes, so now on always tell me I have 5 minutes less than I think I have. Time flies. Okay, so the probability of opting out falls with income. We've seen that, and again, we've replicated this result with other companies that I don't have time to tell you about. This is true. This tendency to stick to the default is true, whether the default savings rate is set low or high. So it's not that low-income people stay at a low default contribution rate because that's where they should be. It's that low-income people, in general, stick to these defaults, whether they're set low or whether they're set high, which means that a high default is pretty toxic for low-income households. So there's a policy recommendation that immediately emerges, which is that we should be setting defaults with low-income households in mind. We should be setting defaults for low-income households, because they're the ones who are going to stick. The high-income households have the agency and efficacy and confidence to make the move out of the default. And it's the low-income households that tend disproportionately to stick at these defaults. Thank you.